Hello students, this is Mr. Boyd. Welcome back for another algebra lesson. Today's lesson is going to be on absolute value inequalities. So solving an absolute value inequalities, we combine the strategies we learned in compound inequalities and solving absolute value equations. Every absolute value inequality is a compound inequality. In fact, that's where we get the compound inequalities from. The two separate inequalities come when you split the inequality once, and the absolute value is after the absolute value is isolated. Remember, you want to isolate that absolute value first, like we learned in the previous lesson on absolute value equations. So again, let's run through the steps. First, you want to isolate the absolute value. Once it's isolated, you choose whether the problem is an and problem or an or problem. Here's how you do that. If it's a greater than or equal to, it's an or problem. If it's a less than or equal to, it's an and problem. Really the key here is whether it is a greater than, it's an or whether it's a less than, it's an or. The equal to really has no bearing on whether it's an and or an or. Next, split the absolute value into a compound inequality, and as we've done in the previous lessons, we're going to solve. Remember that the previous lesson on absolute value equations, we will have a positive and we will have a negative. Okay, let's see how that works out in these first examples. Here we're just asked to set up the compound. So let's see how that works. So this one is pointing away, so this is obviously an or problem. So I need a positive and I need a negative with the word or between it. So I would have x is greater than 3 or negative x, the opposite of x, is greater than 3. Okay? So to finally solve this one on the right, we will divide by -1, just like we did in the previous lesson on absolute value equations. And we see that x is less than -3, and it becomes less than because we divided by a negative number. Okay? I'm going to jump one. I'm going to let you guys come back to the your turns for the purpose of this video. Okay, here I notice that the absolute value expression is already isolated. So I can go ahead and break this down into a positive inequality and a negative inequality. So here again, I will have x is less than or equal to 8. This is a less than, so this is an and compound. And negative x is less than or equal to 8. Okay, so here this one's already solved out. Over here we need to solve it. So we will divide by -1 again. Don't forget to flip the inequality symbol. And so we see that x is greater than or equal to -8. Now if we put this together in one complete statement, we would have -8 is less than or equal to x is less than or equal to +8. Back over here on the first one, we would have -3 is less than, oh, no, I'm wrong on that one because this is an or. You cannot write that like this. Okay, why don't you guys pause the video and try the your turn. Okay guys, so here are the answers to the your turns. Go ahead and check them and see how you did. All right, moving along. We have special situations when solving about absolute value inequalities. So to take a look at those, what are the solutions of these? Okay, so absolute value equals a negative number. We know that that is a no solution. Because absolute value cannot equal a negative number. Let's move on to this inequality. This says that the absolute value is less than -10. When I think about that, less than -10, that's just more negative numbers. That's like the first one. That's like saying 4x plus 2 equals a negative number. So again, this is going to be a no solution problem. Okay. Inequality C. I see that I've got an absolute value greater than negative 10. When I think about that, it doesn't really matter what number I put in for x. I'll always get an answer greater than negative 10. So this one would be all real numbers. Okay, let's move along to our worked examples here and see how these things work out for us. Okay, this first one, notice that the absolute value is isolated. So I can go ahead and write my two inequalities. I need my positive and I need my negative. And this one happens to be an OR. How do I know it's an OR? Because it's greater than. So my two inequalities would be 5x minus 10 is greater than 15. Notice it looks just like what the problem looks like. And then the second one would be the opposite of 5x minus 10 is greater than 15. Okay? Now to solve these, we use the same rules that we used before with inequalities. So here we're going to use inverse operations and add 10 to both sides. And that's going to give us 5x is greater than 25. And then we will divide by 5 to isolate that x. And so x is greater than 5. Okay, let's look over here at this one. All right, remember, if there is no number here behind that negative, then that's a negative 1. Now I could distribute here, but I'm going to choose not to, just like in yesterday's lesson. So I'm going to divide by negative 1 here to get rid of that negative sign. And that's going to leave me with 5x minus 10, because these cancel each other out. I divided by a negative, so I need to flip the inequality symbol and put negative 15 over here, because 15 divided by negative 1 is negative 15. And then again, we're going to use our inverse operations to solve this. So I'm going to add 10 to both sides, leaving me with 5x is less than negative 5. Then I'll divide by 5, which gives me x is less than negative 1. Okay, so let's go ahead and graph this. 0, negative 1, 1, 2, 3, 4, and 5. Again, this is an OR. This says x is greater than 5, so that's an open circle, shaded to the right. X is less than negative 1, that's an open circle, shaded to the left. And for this to be true, at least one of these needs to be true, not both of them, because this is an OR statement. Okay? I'm going to move on through the examples for the purpose of this video. If you want to see the answers to the your turns, you can find those in the notes in the notebook. All right, let's move on to this next one. So here, I need to isolate the absolute value. So we're going to subtract 9. That's going to give us negative 4 times 3x minus 6 is greater than or equal to negative 36. Next, we need to divide by negative 4 to undo that multiplication. Remember, we do not want to distribute there. We want to divide. Okay, this gives us the absolute value of 3x minus 6. Less than or equal to, got to flip that over because we divided by a negative here, by positive 9. So now I can write those two inequalities. I need the positive and I need the negative. This happens to be a less than at this point, so this is an and. What tells me that is this symbol right here when I have the absolute value isolated. So my two inequalities would be 3x minus 6 is less than or equal to 9, and 3x minus 6 is the opposite of 3x minus 6, is less than 9. Again, we'll start off by adding 6. We'll solve this using our normal methods. That leaves me with 3x less than or equal to 3. Then I'll divide by 3, leaving me with x is less than or equal to 1. And, all right, over here again, I've got a negative 1 out here. So I'm going to divide by negative 1 instead of distributing. That leaves me with 3x minus 6 is greater than or equal to, don't forget to flip it because we divided by a negative, greater than or equal to negative 9. And then again, I'll isolate the variable. So I'll add 6 to both sides. That leaves me with 3x is greater than or equal to negative 3. And then here I'll divide by 3 again. And that's going to leave me with x is greater than or equal to negative 1. So here I see my solution set is x is less than or equal to 1 and x is greater than or equal to negative 1. And I can write that into one concise statement by saying x is less than or equal to 1 and x is greater than or equal to negative 1. And then, of course, we would graph it just like we did the and compounds in previous lessons. Okay. Let's go ahead and jump down, and I want you guys to try this next one and then see how you do. Pause the video, try this one, and I'm going to work it out for you. Guys, I went ahead and worked this out and wanted you to check your work, but I wanted to unpause the video and show you guys the graph. So I've already graphed x is less than or equal to 1/3. Remember, that's a solid circle shaded to the left. Well, when I do x is greater than or equal to negative 2 1/3, negative 2 1/3 right here, and I'm shading greater than, so I'm shading this direction. And because this is an OR problem, which means at least one is true, notice I've really shaded the entire number line. That's why if it's greater than or equal to a negative number, the solution set is all real numbers. Okay, let's see what happens with this next one real quick. To isolate the absolute value, I'm going to subtract 49 from both sides. That's going to give me the absolute value of 2x minus 7 is greater than negative, let's see, 49 minus 27. Let's see, that's a 2, 22, negative 22. Okay, again, I've got absolute value greater than a negative number. I don't need to work that out as seen in the previous example. So the solution set would be all real numbers. Okay, what is the difference between less than and greater than when solving absolute value inequalities? I'm going to ask you to pause the video and write the answer down to that and then come back and check it against my answer. Okay guys, here's the answer to mine. Go ahead and check that and see how you did. And if you enjoyed this video or got some help from it, go ahead and click subscribe to see some of the other videos I put out. At the bottom here for my students, these are the 6 homework problems that I expect you to complete for tonight's homework. Have a great day.